Good afternoon, Rich Nass, Executive Vice President with Open Systems Media and leader of the Embedded Computing Design franchise. I am here for this week's Embedded Executive Podcast. This week, my embedded executive is Amir Panoush, and he is the CEO of Ceva. How you doing, Amir?
Very good, thanks. Good morning, Rich.
So we want to talk about what we seem to talk about in almost every conversation these days, edge-based AI. But your link to this discussion has to do with IP. You guys do IP. So where does, well, I'm not sure how to frame the first question. Is this an IP discussion we should be having when we're talking about edge-based AI, or is it something bigger than that?
So to the most part, we provide an IP, and the discussion is really about how we enable our silicon partners and customers to utilize our predefined IP into their system for their AI systems. But generally speaking, of course, we can look at all different use cases and where that can fit in order to enable the overall AI at the edge.
What are the use cases that you're referring to?
So overall, when we look at the so-called the smart edge, we're talking about first about 4 key markets. Basically, all the consumer IoT, the industrial IoT, all the devices around us that are connected and needs to make decisions, so-called smart decisions, as well as the wireless and wired infrastructure, as well as the automotive markets. Within that, there are many, many different use cases, from things related to predictive maintenance, to audio enhancements, to vision enhancements, sensor fusion, and many other type of use cases.
Okay, you mentioned the smart edge. Is that something different than what I think it might be? What is your definition of the smart edge?
So when we look at the smart edge, we're really looking at the device that basically have 3 major use cases coming together to enable a decision within the device. The connect being wired or wirelessly connected to the infrastructure, the ability to sense the environments, and then with that go and make decisions, so-called the infer, and this is the AI parts of those solutions. And when we talk about the edge, basically we're talking all the devices that are not in the cloud, they are around us, and basically they can also be embedded into the different type of products out there.
Okay. Are you of the opinion that TinyML is the right direction that people should be going? Does that have the capabilities to do what people want from the smart edge?
Yeah, definitely. As we look so-called more into the far edge, where you have embedded systems that are battery operated, they need to run from anywhere from a day to weeks or even years. You need to be able to run neural networks that are based on small footprint in terms of the complexity of the model or the number of parameters, typically anywhere up to 10 megabytes, as well as very efficiently on power. Instead of driving watts of power, really driving milliwatts of power in order to enable that usability, and so-called the always-on use cases. For that purpose, TinyML is really a great solution to provide the capabilities at the edge.
Is TinyML getting the due that it deserves for this application? Because I don't hear it a lot.
If we look at the AI overall, I think, the early beginning and where basically the discussion today is about the cloud and the training, everything related to Gen AI. And we at Ceva have solution for that as well. But really, as we look towards in the coming few years, what we see is the transition to a hybrid model of how to basically drive AI capabilities. And with that and the embedded devices, you need to be able to make local decision with the privacy, with the localization, and be very power and cost efficient. And that's where we will see basically TinyML taking place. And the expectation overall in the markets that by, in a few years, by 2028, there will be roughly about 4 billion devices out there using TinyML. And our IP and others IP alike will enable that to also use with a dedicated AI acceleration and capabilities within those devices. And so we expect more than 70% of overall those 4 billion devices to use a dedicated NPU or neural processing units to support the TinyML use cases.
Okay, I should have done this at the beginning, and I apologize I didn't. Would you just give us the 30-second of who Ceva is and what you guys do and what makes you different?
Yeah, definitely. So Ceva we are a public company that have been around for 2 decades now. We started with a DSP, a leader in wireless communication in the cellular space. Then we diversified with multiple wireless communication technology, Bluetooth, Wi-Fi, UWB, and so on, for all the different smart edge markets, the four that I mentioned: industrial, consumer IoT, automotive, and wireless infrastructure. And more recently, we added lots of IP capabilities related to AI, from generative AI, the large models that you need to run on handheld devices to drive the hybrid inference capabilities. And now all the way with the new product we just announced, NeuPro Nano, for TinyML use cases.
So why Ceva over somebody else?
When we look at Ceva and our heritage as really a leader with DSP processing capabilities for all the things related to sensing, audio, vision, and wireless communication, that's the core of all those smart edge devices. We have the understanding of the wireless communication, the processing capabilities, and now how to take it to create very power efficient AI capabilities on the edge. We always, basically, in all our IP, we always combine a very great capabilities of high performance with the lowest power, efficient, and capabilities, which is really great fit for the smart edge. And we are targeting that markets rather than the cloud base on the infrastructure.
Okay. So I'm on the record as saying if we project out maybe 2 years, AI will be something that we don't talk about it anymore. It'll just be there. It'll be a thing that is embedded into all of our devices and we won't really have to worry about it. Do you agree with that belief?
Yeah, very much so. And the analogy that I will do is like the IoT or the connected device connectivity. Everyone talked about it. It will take time and all that. But today we can literally think about a device that is not connected, and it's part of the overall the IoT or the different edge devices around us. What's coming right now is to add to that so-called the smartness or the inference or the AI capabilities to make it even more capable devices on the edge with the localization, privacy, power efficiency, and cost structure that is needed.
You stole my example. I use that IoT example all the time.
Good.
Very good.
I think I like.
So going back to AI, do we have the ecosystem in place now to make that happen, or are there still things that have to happen before we get there?
I think as actually with the IoT, that's not going to be a one-step function. It will be evolution that will happen over time. We are very encouraged to see that there is lots of, in terms of the cross compiler, all the software stack on top of that from the open community. There is lots of open source that is coming to really create so-called more a market standards of how to utilize those devices, as well as we are very happy to see lots of our partners and so-called MCU providers out there are aligning more and more on what kind of capabilities they need to add to their connected devices in order to add the infer or the AI TinyML capabilities.
Very good. Well, I look forward to seeing how all this plays out, and hopefully we're both right, because we seem to be on the same page with all this stuff. Thank you, Amir. I appreciate your time.
Also appreciate very much your time, Rich, and looking forward to that success for us and the rest of the market.
Absolutely. That was Amir Panush. He is the CEO of Ceva, and I am Rich Nass with Open Systems Media.